Hi everybody, welcome to Make the Grade. My name is Caroline Richardson, and today, as in most weeks, for the last 18 weeks I guess, I am here to help you with your math. So, two things. If you have questions on your homework or a concept you're not sure how to work out, just give me a call. There's going to be a number that appears at the bottom of your screen. Just give me a call and I will show you how to do it. Now if you have to leave the TV, we're also on the web, and I'm going to give you that website in a second. The second thing is today I'm also going to be working on EOG review questions, okay? Those EOGs are coming up next week for the 6th, 7th, and 8th grade, and I want to take some time just to go over some sample questions and give you some strategies that you might want to look at, and give you some shortcuts on how to just answer the question. Now, if you have a question that's not an EOG question, just give me a call. I'll take a break in between those questions and try to answer them, okay? And parents, this is also for you. These are samples of questions that you might want, or if you're working on homework and you're just not quite sure how to handle it, just give me a call and we'll tackle it, okay? So first let me give you the phone number straight up. Okay. All right, phone number, there we go, is 217-2203. And just give me a call, the phone will ring, and Karen Kelly will answer it and take your question, and I'll get to it as soon as I can. Also, well, not now because I'm not near the computer, but throughout the week, if you want to email me a question that I can work out for you, I'll answer you throughout the week, and I make sure that I look at it right before I come to the show today, and that's mathhelp@wcpss.net. And then the show is live on the web if you can't get near the TV, or those of you who are watching where it's not being broadcast, you can go to http://ewtv.org for East Wake Television, and it'll prompt you for what type of connection you have. Look for Make the Grade, and I'll be there waiting for you, okay? So we are going to get started today with some, on Tuesday I had an opportunity to do some 6th grade problems and some 7th grade sample problems for the EOG. What I'm going to do today is I'm going to start with the 8th grade EOG, and I'm going to start with goal 1, and I'll explain that in a moment. And now if you don't have these questions, you can get a copy of these questions by going to the Wake County website, which is www.wcpss.net. Go there and do a search for Make the Grade, or there'll probably be a prompt there for a testing review on the left. Go to that link, and there'll be some download files there for you to look at. That'll be some practice problems. If you don't see them there, then you can also go to the Department of Public Instruction website, which I'm not quite sure of that, but do a search on Department of Public Instruction for North Carolina, and I'll look that up for you here in a second, and do a search for those EOG type questions, okay? And that's what I'm working from. So these are samples from previous tests or sample items that they've posted out there that are typical of what you might see. All right, let's look at the 8th grade goals real quick. I'm going to zoom in just a little bit so you can see. Zoop! Always goes so fast. There we go. All right, goal 1, number and operations. The learner will understand and compute with real numbers. Real numbers, we have moved beyond the rational numbers, which is what was showing up in the 6th and 7th grade. So real numbers not only are rational, but we're also dealing with irrational numbers. Irrational numbers might be some of your square roots, like square root of 2, square root of 3, those sort of things. 10 to 15% of the questions on the test are going to deal with specific operations just like that. Actually, what you're going to see is that this goal will be wrapped in with some of the other goals. The second concept is measurement, second goal. The learner will understand and use measurement concepts. Again, 10 to 15% of the test, or the questions on the test. Geometry, the learner will understand and use properties and relationships of geometry. Some of the basic shapes that you've been going over, some of your basic formulas, like the area of a triangle, area of a square, that sort of thing, things that you should have already put to memory. 10 to 15% of the questions will be on geometry. Data analysis and probability. The learner will understand and use graphs and data analysis. 20 to 25% of the questions. So the importance level, not that goals 1, 2, and 3 are not important, but there's going to be more questions dealing with data analysis. And that kind of goes along with, if you look at goal number 5, algebra. The learner will understand and use linear relations and functions. So not just not some of our relations that you had in some of your lower grades, but now you're also dealing with functions. 35 to 40% of the test is based on algebra. Okay, that's all. We're getting close to half of the test is on algebra. So what will happen is the problems from goal 1 dealing with real numbers probably will be put and wrapped up with some of the algebra. Also your data analysis, you can look at me. Also the data analysis, think about when your teacher might have given you scatter plots or a lot of data, and you had all this data and you had to see what the trend was, what kind of graph it would make if you were to plot it. That type of data analysis will also be coupled in with the algebra. Okay. All right, so I'm going to start with goal 1 just to get us warmed up today, which is dealing with numbers and operations and dealing with your real numbers. A lot of the test, and this is true for 6th, 7th, and 8th grade, a lot of the test the test is very calculator driven. So it's not that I don't want you to know the mathematics. I certainly want you to understand the concept. And I'm going to take a few minutes and remind you of the concept. But I also want you to be very familiar with your calculator and use it as a tool to be successful on the test. Okay? All right, let's look at the first one. There we go. All right, this one says, can you read it? Zoom in just a little bit more. I'm never sure if they can see it. There we go. A surveyor determined that the distance across a pond is the square root of 2,255 feet. Approximately, what is this distance? So we can already see that our answers are in decimal form. So how would you take the square root of 2,255 feet, and how would you convert this radical into a decimal? Well, real simple. Now, you could try to do it by hand. In fact, I know my father, probably when I was 15, which I won't tell you how long ago that was, tried to show me how to do long square roots. And you know what? I don't think I could tell you. So you know what? We're going to look at the calculator. So flip over to the calculator. Square root of what? 2,255. I keep saying that. Get in the habit of closing your parentheses. It'll make your life easier later on. Enter is approximately 47.486. So if we look at our answers, which one matches that? 22 is way off, 25. Oh, look at that, 47.5. There we go. Now look at some of these other answers. See, look at this one, 1,127.5. Can you see any relationship between that number and the number that's under the radical? I bet, and let me just check it because I didn't test it, but look at the calculator, 2255 divided by 2. Oh, look at that. So what they might do is there's always going to be questions on there. There's always going to be answers on there that, I won't say always, but I'm going to say always. I feel pretty good about this statement. There's always going to be answers on there that if you do the wrong operation, that answer will be there. And a square root, to get to that number, it would be a number that you squared, raised to the power of 2, can sometimes get mixed up with divide by 2. And they want to be sure that you really understand how to do radicals. So watch for those answers, okay? All right, the other thing is always try to check your work because that answer really showed up. You know, D was an option when you divided by 2, but it was the wrong operation. All right, so that was a real quick one on the calculator. I'm like, how can that be real quick if you kept talking? I could talk about these forever. All right, let's look at problem 2. Let me put these over here. There we go. The area of a square is 800 square meters. The length of its side is between which two numbers? Well, first thing I would do is I would try to visualize what's going on. So the area of a square, area of the square is equal to 800, oops, try that again. The area of the square is equal to 800 square meters. Okay. How do you find the area of a square? That should be a formula you should know. If I have the sides, which all the sides are congruent, correct? The area of a square is equal to the side squared. So there's our recipe, and we already know what the product should be, okay? So s squared, or side squared, should equal 800. How would you solve for just s? Well, the only way to get the s by itself is to do the opposite of squaring something, which would be the square root. So the square root of s squared is equal to the square root of 800. S is equal to the square root of 800. We can pop over to the calculator. Square root of 800 is, and it would be plus and minus. You probably haven't done that in 8th grade, have you? But, oh, they have? Okay, so you would have both roots. So 28.28. Now, if we're talking about the length of a square, would we even worry about the negative one? No, we would not. So really, what we're dealing with is positive 28.28. So the question is which side is it between which two numbers? Between 27 and 28, between 28 and 29, 200 and 201, 400 and 401. Well, A and B look pretty close. This one is one of those ones where you need to be very, very careful that you don't read the answers too quickly. So 28.28 is definitely between 28 and 29. So our answer is B. A is just one that you looked too quickly. You saw the 28, and that would just be why you would bubble A. Where do you think C and D are coming from? Well, I'll tell you. What is 800 divided by 4, which is the 4 sides? 800 divided by 4 is 200, isn't it? Okay, so that might be a way that you got the 200, because you thought you had to divide that whole number by 4 and split up the 800. Where do you think this 400 came from? 400 came from, just like we did before, 800 divided by 2, not s squared, but 2, you're thinking it was 2s, gave you that 400. So be very, very careful. They've used the same numbers that you would do, that 2 and the 4, but in different methods. Okay, so the answer is B. Great. It's a good one, tricky, okay? And these are the ones that you want to be sure that these are the easier ones, I would say. So these are the ones you want to be sure that you just read your answers carefully and be sure that you understand the basic concept with the real numbers, okay? And let that calculator help you. All right, let's look at number 3. Which of the following is the perimeter of a square whose side measures 3 plus square root of 2 units? And you notice as I'm going through, I'm underlining words like perimeter and square. Do you think I'm doing that for your benefit? Well, you know what? I would be doing that even if you weren't watching me, because these are key words. Which of the following is, blah, blah. Okay, that's just the words leading up to it. But perimeter of a square whose sides measure 3 plus square root of 2 units, okay? So let's get a square up there. And a basic property you know about your squares. See, remember I told you that goal about geometry. What was that? Goal 3. Goal 3 about geometry. It's going to be intertwined with some of the other goals. Here's an example. Geometry, you should know that one thing you should know about a square is that all the sides are congruent, or all the sides are the same length. So we know that this side is 3 plus square root of 2. This side is 3 plus square root of 2. This side is 3 plus square root of 2. And this side is 3 plus square root of 2. The question is, what is the perimeter? Well, how do you find perimeter of a square? Well, how do you find the perimeter of anything? Perimeter of anything, any polygon, let me take that back. Perimeter of any polygon is you add up all the sides. So we could quicken this idea with a perimeter of a square. You know that all 4 sides are the same, so you could say 4 times the side if you wanted to. Either way, whatever is more comfortable for you. You can add them all up or say 4 times the side. Now, also, let's look at our answers. One of these or 2 of these answers are in decimal form, which means we're going to have to take these radicals and turn them into decimals. And 2 of the answers are in radical form. All right, so let's go ahead and handle this with the formula 4 times the side, which is 3 plus radical 2. How would we solve that? Well, this is the perimeter of the square. We would distribute that 4. 4 times 3 is 12. Carry down the sign. 4 times radical 2, well, we'd kind of treat that like a variable, if you recall, and there's a 1 in front of that. So 1 square root of 2. So 4 times 1 is 4 radical 2's now. Is that one of our choices? Sure is. Now, if you had done that math and it didn't turn out to be one of those choices, then this is where you would type it into the calculator. So let's just see what the decimal equivalent was if we look at the calculator. 12 plus 4 times the square root of 2 is 17.65, so about 17.7. So if we come back over here, that wasn't even close to one of our answers. So if you wanted to double check your answer to see. But D is the right one. Now, where are these other ones coming from? Look at C. See when I distributed? A very common error when you distribute, find the 4 times 3, we would have gotten the 12. 4 times square root of 2, see where they got square root of 8? So the general rule is if I have, let's say, a square root of x times b square root of y, it's kind of a general form of it, outsides times outsides, so that's a times b, insides times insides, x and y, okay? So let me scoot up a little bit. So you don't want to mix that up. When they did part C, they took that 4 and they multiplied it under the radical, and that's not allowed. Outsides to outsides, insides to insides. Kind of a rule of thumb with the radicals. All right, wonderful. Good job. Another radical problem. So what are those radicals? Those radicals are those irrational numbers. Or, well, they could be rational numbers too, but they're your real numbers, okay? Number 4. The area of a triangle is 51 square meters. The height is half the length of the base. What is the approximate, so it doesn't have to be exact, height of the triangle? When I see words like approximate, that's telling me, look at me, when you have a square root of 2, that is an exact number. If I said the square root of 2 or the square root of 3, that is an exact number. If I type into the calculator, look over here, if I type in the square root of 2 and hit enter, the calculator is saying 1.41421356.2. Do you know, it hasn't ended there. It only ends with 2 because that's as far as my calculator will go. The square root of 2 is an irrational number. It goes on forever, just like pi. It just keeps going. So the calculator is what's truncating that. So sometimes when it says give an exact answer, you might write down those 10 digits that appeared on the calculator, but that's not exact either. That's been rounded off by the calculator. The exact answer would be square root of 2. It's exactly the square root of 2, whatever that might be. Now, is that practical? Well, it's practical if we're just doing some basic math problems and the square root of 2 is representing not something physical per se, but it's part of the numbers that are involved in the formula. But if you were cutting a piece of wood, and I think I've said this before, if somebody said, would you cut the square root of 2 inches, please? You would look at them like, what are you talking about? I have no idea what you're talking about. So you would say, oh, would you cut it to about 1.4 inches? And that's probably okay. Now, when aren't you going to want to round? Well, what if a doctor is doing laser eye surgery on you? Would you want them to be as exact as possible? Or would you want them to say, yeah, cut into it about 1.4 millimeters or micrometers probably? No. No, okay? You'd want it to be as exact as possible. And you'd take that decimal out 10 digits, or you'd let the calculator or the computer, whatever's calibrating, square root of 2. That's fine, okay? So there are times where you're going to want that number to be exact. I would think your laser eye surgery might be one of them. All right, so enough on that soapbox. All right, come back to the problem. It's like, how does she take a 1-minute problem and turn it into 10 minutes? I don't know, I'm good. All right, so the area of a triangle is 51 square meters. Area of a triangle. What is the recipe for the area of a triangle? Area of a triangle is equal to 1/2 base times height. And they are not going to have any formulas on this test, correct? Correct. So you need to be sure that some of the basic formulas that you need, and I'll find you a formula sheet and pop that up maybe next week. And your teacher, ask your teacher too, but some of the basic formulas like the area of a square, area of a triangle, area of a circle, those sort of basic formulas that you've been working with probably since 6th grade, you should have committed to memory, all right? All right, so here's the recipe. Area of a triangle is equal to 1/2 base times height. Then it says the height is, so the height is, that's equals 1/2 the length of the base. 1/2 the base. What is the approximate height of the triangle? So here's a situation where we know that the area of the triangle is 51. 51 equals 1/2 base times height. The problem is we have two variables, but not really, because look at this. H, or the height, is equal to 1/2 of b. So everywhere we see h in our original recipe, we can replace it with 1/2 b. So let's do that. So 51 equals 1/2 base times height. Well, the new value of height is 1/2 b. All right, so we just did a substitution. Very nice. So now we go ahead and solve. We have 51 is equal to 1/2, let's put our numbers together. 1/2 times 1/2 b times b. And why are we allowed to do that? Commutative and associative property, right? You can regroup and reorganize. So 51 is equal to, what's 1/2 times 1/2? 1/4, good, not 1. And I bet one of these answers is thinking that you put those together as 1. B squared. We need to isolate the b alone, so we're going to multiply both sides by 4/1. 4/1. 51 times 4 is 204. So 204 equals b squared. So now how do we solve for b? Well, this means b squared, the opposite operation of that would be the square root. So the square root of b squared, whatever you do to one side, you have to do to the other. And in algebra, you can do whatever you want. So b is equal to, well, what is the square root of 204 is about 14.28. And about, we wouldn't have that equal sign. You'd have that little double squiggle there if you ever see that. So b equals about 14.28. So now I've come up with an answer. So now I need to come back up and look at our choices and see which one is working for us. What's the approximate height of the triangle? Well, 7 and 7.1 aren't even close. 14.0 or 14.3, which is closer? Well, we want the most exact answer we can, or not the most exact, we want the closest approximation we can get. So this one, if we round it, would be 14.3, and that's a much better approximation than just 14. There we go. The answer is D. Now, where do you think the 7 is coming from? Well, I bet you, yep, I bet the 7 is coming from, if you did 1/2 and you came up with 1, if we made that 1b squared equals 51, the square root of 51, I bet is a little over 7. Let's look. The square root of 51, sure is, look at that, 7.14. Square root of 51 is about 7 point, what did I say, 14, so 1, and that's choice B. Look at that. So what were they counting on you doing? Or not counting on you doing, but one of the answers they have there is that instead of taking 1/2 times 1/2 and getting a 4th, you did 1/2 plus 1/2 and got 1. So this problem wasn't even trying to see if you could understand the formula. The errors that they were looking for, I don't want to say they're looking for. They're not really trying to trick you. They just want to be sure. Look at me. They're not really going out of their way to try to trick you. These are just some of the common errors. When you have 1/2 and 1/2, you instantly think, oh, I have 2 halves. That makes a whole. But multiplication, you multiply numerators, multiply denominators. So just remember all your arithmetic. Okay? Don't let the arithmetic mess you up. Don't let any of it mess you up, because you can do this, all right? And if in doubt, don't be proud. Just type it in your calculator. I know you can do that one in your head, but if you're unsure in the least bit, just type in 1/2 times 1/2. And you should be able to, and I'll just do it real quick, you should be able to do fractions on this calculator. I would open a parentheses and say 1 divided by 2. See how that looks like a pretty slanty fraction? Times 1 divided by 2. See, they would look like pretty slanty fractions. And you get 0.25, or you can hit the math button and say you want the answer as a fraction, and there's the 1/4. Okay, so let the calculator handle that if you get unsure at all. All right. Yay. Problem 5. This is the last problem that I'm going to go over that has to do with goal 1, which is dealing with the numbers, and then I'm going to do some algebra with you. And 6th and 7th grade, the algebra problems I go over will benefit you as well. In fact, all of these are benefiting all of you. All right, let's look at number 5. The drama club is selling tickets to a play for $10 each. The cost to rent the theater and costumes is $500. In addition, the printers are charging $1 per ticket to print the tickets. How many tickets must the drama club sell to make a profit? Okay, come back to me. I mentioned this before, and I'm going to be really passionate about this. It's a math word problem has maybe 3 sentences in it. Read it one time just to get a gist for the problem. Read it a second time to pick out some of your facts. And at the very end, read it a 3rd time just so you can be sure you answered the question. It's not like reading a novel where you have to read it 3 or 4 times and read page upon page. Just read the problem several times. We get very caught up, and you know what? Teachers are almost the worst at this. We scan a word problem really quickly and we pick out numbers because we want to try to answer it for you quickly. Just take the time to understand the problem. Every word, especially on the EOGs and EOCs and SATs and any other standardized test you take, every word is important. It might mean something, okay? All right, so let's go back. So the drama club. Now, you should be able to picture yourself. You're in a club. You're selling tickets to the play for $10 each. The cost to rent the theater is $500. So let's get a few things organized. What if I said X is the number of tickets? Because that's what I don't know. I need to know how many tickets I must sell to make a profit. So we'll let X be the number of tickets. And if we try to set up how we would calculate how much profit we made or how much money we've made, the cost of a ticket equals the rent plus the number of tickets. Actually, it's more like the cost of the tickets, the cost of the play. So you're going to have your rent, and you're going to have the number of tickets. So we would say 10x, because it's $10 for each ticket, is equal to 500, which is how much it costs to rent the theater and the costumes, plus the number of tickets, which we're not sure, which is x. Because, oh, that's right, because it's $1, so we'll say 1x just to make that clear. So it's $1 per ticket, so the number of tickets for the printer. Let's make that a little bit more clear. And sometimes it's a lot easier if you just take the time to work this out in words. All right, so 10x equals 500 plus x. We can go ahead and solve at this point. So subtract x from both sides. We're left with 9x equals 500. Divide both sides by 9. We're left with x is equal to approximately 55.5 repeating. So the question is how many tickets must the drama club sell to make a profit? Well, this was the actual cost. This was equal to. So can you sell 55 and 5 repeating? No. To make that profit, we're going to need to sell at least one more. So more than 55, 56. So if they sell at least 56 tickets, they've made a profit. Now, if they sell 57, will they have made a profit? Yes. But that's not, in fact, you could have 357 down here if you wanted to. That's not really the question. Look for the very first one that's going to start making the profit. And then if somebody wanted to pursue this, we could actually graph our answers and say, okay, anything above 56 is going to make me profit. All right, so it all depends on how the question is worded. Where do you think 54 and 55 are coming from? 55 is coming from a rounding issue, and 54, I don't know, maybe rounding as well. It's hard to say. All right, so there's always going to be some answers floating around up there. Okay, so you can still call. Remember, you can still go ahead and give me a call if you have questions on some of your homework. I know your teachers are giving you lots of review, and if you're not sure about something that I'm going over, or your teacher showed you a different way and you want to call me and see if it's okay to do it that way, that's great. All right, I'd like to go over the algebra goal. So just a reminder that algebra, the learner will understand and use linear relations. And see, I just had to prompt you to call. 35 to 40% of the test is based off that goal. So let's look at number 1. Which set of ordered pairs represents a linear relationship? There's several different ways you can do this. First way you could do it is you could graph it. You could graph all 4 of these and see if you could take in fact, let's just do the first one to show you. If we take this first one, put some graph paper up there. If we go ahead and plot this first one, 0, 1, and be exact, 0, 1, 0, negative 1, negative 1, 1, negative 1, 2. Okay, the question is it a linear relationship? What does that mean? Linear relationship means, is it a line? Does it make a line? Well, you could connect them, and it does make a line, but there's a bend in the line. So it's, by definition, the line is supposed to be straight, right? Collinear, all in alignment. So letter A does not represent that sort of relationship. The next thing you could do, we could do that with all of them. The other thing you could do is you could go ahead and look at the ordered pairs and see if there's a pattern between them. So let's do that. Oops, sorry about that. So if I made a simple XY chart, and I put in each one of my coordinates. So I said 2, 2, 3, 3, 4, 3, 5, 3. What's the difference between 2 and 2? 0. Difference between 3 and 3? 0. Difference between 4 and 3? 1. Difference between 5 and 3? 2. If it's a linear relationship, everything's going to always work out to be the same. And you can always double check yourself. Again, by plotting. Let's pick a different color. Let's pick teal. 2, 2, 1, 2, 1, 2. There we go. 3, 3, 1, 2, 3, 1, 2, 3. Looks good so far. 4, 3, 1, 2, 3, 4, 1, 2, 3. See how all of a sudden we got it? And then 5, 3. So again, that didn't work. All right, so let's, you can take the time to plot it if you want to. Otherwise, let's just see if we can see the relationship. So the next one, this was B, so B is off. Let's do C. In algebra, this is something, the algebra EOC people, this is worth you looking at as well, because this is the same type of problems you might see. So negative 1, negative 4, negative 1, 0, 4, 3, 5, 3. What's the difference between negative 1 and negative 4? It's a difference of 3. Difference between negative 1 and 0 is 1. Difference between 4 and 3, 1. Difference between 5 and 3, 2. If this was linear, the difference between them would always be the same. So C is out, and let's look at D. And again, you can plot them to double check yourself. 2, 3, 3, 4, 4, 5, 5, 6. Difference between 2 and 3 is 1. Difference between 3 and 4 is 1. 4 and 5 is 1. 5 and 6 is 1. So this one looks very promising. So let's go ahead and plot that just to be sure. And now we're going to choose red. Celebrate diversity on graphing. Look at this. So 2 and 3. So 1, 2, 1, 2, 3. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 1. No. Focus. 1, 2, 3, 4, 5. What did I do wrong? 1, 2, 3, 4, 5. There we go. To count. 1, 2, 3, 4, 5, 6. Whew! And sure enough, they make a line. And don't confuse, just because there was a difference between them, really what I'm leading up to is the same slope, right? We want them to have the same slope all the way through. When you go up a set of stairs, you're always rising and running at the same rate. That's how we know it's linear. Great. Algebra. I've lost my sheet. Problem 2. Again, more with the graphs. Is there another way that you could have done that problem? You probably could have put those answers or choices into the calculator and plotted them on StatPlot. I think that would have taken you a lot longer than you need to analyze that problem. All right, let's look at this one. This is a little bit tiny, so I'm going to blow it up. The question is a little bit tiny. I don't know if you can see it. Woo! There we go. That's workable, right? What is the graph of x equals y? X equals y. Two ways we can handle this. First of all, most of you are used to seeing it y equals x, okay? Go to your calculator. Just go to your calculator if you're not sure. Now, this is one, to be honest, you should have memorized. This is one, go back out. This is one that you really should have memorized because this is going to come up over and over again in geometry. Where have you seen this? You've seen this when you're doing reflections over the equation y equals x. Algebra 2, you see it. Algebra 3, this is one of those equations that you should just know really quickly. So let's go to, hello, I've got to find my calculator here. Let's go to the calculator. If you haven't memorized this one and they give you any equation they want to know what the graph is, go to your y equals up in the corner. See the y1? Hopefully you know where that is. And type in y equals what? Y equals x. Graph it. Look at that. That is the perfect diagonal that passes through the origin. So if we come back to our answers over here, this one, I don't know if you can see them real well or not. Let me darken them up in red. This one is a vertical line. No. What is the equation of a vertical line? Well, x is, in this case, I can barely read my own graph. 1, 2, 3. I just want to make sure that it was calibrated. So x is 3, and what is y? Y can be anything it wants to be. So if we were to graph this one, we would say x equals 3. Why? Because x is 3 all the time. We don't care what y is. X is 3. Look at this one. This looks very similar to what we had. This is a perfect diagonal, but it is been tipped over to the left, which indicates that it is negative slope. So the equation of this one is y equals negative x, another one that you should memorize. This one right here, look at this. Here's your perfect diagonal passing through the origin. This is y equals x, so there's our answer. And then look at D. D is y is 3. We don't care what x is. X is all the numbers all the time, but y is 3. Y is always 3. Y is 3. So there's those equations. And these are equations that you should be able to pick out and know all the time. Okay? So the answer for this one was C. Just if you're not sure, you want to take a chance, just pop it into your calculator, hit graph, and make sure you know how to do it. And your teacher should have gone over that with you. I have the overhead somewhere, but just look at the calculator real quick. And I know I just want to be sure. Here's the button right up here. I think the overhead, is the overhead in the bag? This is y equals. So when you hit the y equals, it gives you the choice. See a y equals x. All right, good. All right, let's look at problem 3. Problem 3 is also a graph. And I'm going to have to go wide on this one for you. Make sure you can see it. In the equation, y equals 3x. X represents yards, and y represents feet. Which graph is the graph of this equation? So x is the horizontal, y is the feet. So the first thing I would do is just look at your graphs. Feet by yards, feet by yards, feet by yards, feet by yards. Okay, so we're good to go there. Second thing is, what type of equation is this? Y equals 3x. Y equals 3x is a linear equation. How do you know that? Because the highest One of the ways you know that is because the highest exponent in regards to the x is 1. If this had been y equals 3y squared, then it would have been a parabola. Okay? So these are cues that you want to look for. So it definitely has to be a straight line. So looking at our choices, B is gone because see how there's a bend? I think you can see that, yeah. There's a bend in the B line, which is not linear. Okay, so this one's gone. All right, next choice, y equals 3x, y equals 3x. You could look at this and say, what is the y-intercept? Well, I want to say y equals 3x plus 0, so they all hit at 0. So what could we do? Well, we could plot x, y. I know. Let's go to our calculator. Yes, you're just trying to take the test. I know I want you to understand how to do this, but how can we answer this question 100% correctly? Go back to our calculator. Y equals 3x. Done. Graph. Whoop, look at that one. All right, so it's a slanty one. It's a slanty line going in the positive direction of slope. So we come back to our choices. Oh no, look at this. They're all slanting that way. So how are we going to know for sure? Well, you can look at an XY chart. You can make an XY chart. Or on your calculator, you have an XY chart available to you. So let's go back to your calculator. All right, so look at this. You have 0, 0, 1, 3. I'm going to copy some of these over onto my paper just because I want you to be able to see them both. So 0, 0, 1, 3, 2, 6, 3, 9. All right, go back to the graphs. Which one of these matches up? So 0, 0, we know they all matched. Go over 1, go up 3. So A is gone. Let's look at C. Go over 1, up 3, 1, 2, 3. C is gone. Go over 1, up 1, 2, 3. Let's test out the next one in case we made a mistake. 2, 4, over 2, up to 6. There it is. Now, the other way you could have done it is, what is the slope of this line? Well, the number in front of the x, in front of that variable, 3, is slope. So we were looking for an equation that was slope. So without even having to do any of the technology, you could have just come over to this one, started at a point, and said, okay, how can I get to the next point that's a pretty point? I'm sorry, let me zoom in real close. Oh, look at that. That's awesome. All right, so what could I do to get to this next pretty point that's here? I would have gone, remember it's rise over 1, I would have gone up 1 over 3. So that's 1/3 would be slope for this one. And this one didn't count at all. This part C, what would be the slope of that? Well, we know we're on 0, 0. The next pretty point is right here on 1, 1, 2, 2. So what is that? Up 1 over 1. So that gives us a slope of 1. In fact, what is this equation? Y equals x. We just saw it. And then, of course, over to D, which we knew was the correct answer. Up 3, 1, 2, 3, over 1. 3 over 1 equals slope, which is 3. So that works. So use the technology, or you can just remember what your slope is. Okay. Oops. Far too close. You're going to see that in your dreams, aren't you? All right, there we go. Yay. All right, so let those graphing ones. You can use the calculator if you want to, or you can go back and obviously you should be able to know slope. I say obviously, and don't take that the wrong way, but there are a few things that you should be walking out of your 8th grade class with, and hopefully that's one of them. All right, let's look at number 4, another graph. Oh, what are all these graphs? Well, I'm doing the algebra section first of all, so a lot of your algebra that you did should have involved graphing equations of lines. Which equation describes the line graphed below? Well, we'd have to do an awful lot of guess and check to figure out what this line was. So let's look at this and see if we can figure out a few cues. First of all, it has positive slope. Okay, so slope is positive because it's slanting this to the right. Next thing, the y-intercept is 1. So the y-intercept is the coordinate 0, 1. And then what is slope? Well, we could do slope by substituting in 2 points, or we can just do the step method. Here's 2 pretty points. So 1, 2, up over 1. So slope is up 2 over 1. Let's make sure that just another one. Here's a pretty point. Up 2 over 1. So slope is 2. So what is the equation of a line whose slope is 2 and whose y-intercept is 0, 1? Well, y equals mx plus b. M represents slope. B represents the y-coordinate of the y-intercept. So y equals 2x plus 1. All right, let's look at our choices. y equals 2. Oh, no. They're not there. It's not there. I must have done it wrong. Now, don't panic. Look at this. The way I did the problem, I did it in slope-intercept form, y equals mx plus b. But if you look at your answers, let me just zoom in so you can see them. Woo! If you look at your answers have an x. Oh, did I hit something? No, there we go. Have an x. Oh, it's my hand. Hello. Have an x plus the y equal to some magical number we'll call c. Where have you seen this? Well, ax plus by equals c. That's standard form. Standard form is what? Standard form is where it's in this format, ax plus by equals c, where a, b, and c are integers, so there's no fractions or decimals involved, and then a has to be positive. So there's 3 criteria for standard form. So can we take this equation that we had right here, y equals 2x plus 1, and go ahead and put it in standard form? So what does that mean? That means bring your x and y over to the same side. So let's subtract. I need to tilt this. All right. Subtract 2x from both sides. I'm left with negative 2x plus y equals 1. Now what was the other part of the criteria? I said it had to be in ax plus by equals c form, which, okay, I did that. A, b, and c have to be members of the integer set, meaning no fractions and decimals. Okay, no fractions and decimals, check. And the third part is a has to be greater than or equal to 0, meaning a has to be positive. See how the a here is negative? So how can we, I was getting ready to say get rid of, and that's not very good. How can we eliminate the negative in front of the a? Well, what if we multiplied the entire equation by negative 1? So multiply everything by negative 1. All right, so if we do that, that becomes positive 2x minus 1y equals negative 1. Basically just change the sign on everything. All right, so now all 3 of our criteria are there. So is that answer there? 2x minus 3y, or minus y equals negative 1. There it is. And I'm actually very surprised that they didn't have some other combinations in there. So just be careful and watch for it. All right, excellent. So what do you have to remember on this one? You have to remember how to find the equation of a line. We found the equation of a line by finding the y-intercept, or point on the line, and slope. I substituted it into slope-intercept form, y equals mx plus b. Once I looked at my answers and realized they were in standard form, I had to convert it to standard form. Hello? So let's go out a little bit more. I had to convert it to standard form, remembering the 3 criteria. What it looks like, a, b, and c are integers, and a has to be positive. All right. Great problem. Involved a little bit of everything. Now, is there another way that you could have tested that? Sure. You could have taken your original answer, y equals 2x plus 1. You could have substituted that into the calculator and see if you got the same graph. So there's another way you could have tested your answer and checked your work. All right. Good job. Is this a call? This is a call. All right. Suppose the equation, let me back off a little bit. Suppose the equation h equals negative 16t squared, there we go, plus 35t models the altitude of a football. Will reach, keep talking, will reach in t seconds after it is kicked. Is the given altitude possible? So if we just visualize it for a second, the substitute on. One of the things you can do is just looking at this, think about what's happening with a football. The football is being kicked, it arcs, and it comes back down. So this is basically a parabola, correct? All right, so one of the things we can do is its altitude possible? We can take one of the things we can do is test and check. We can put the 16 into this and see if it works, or see what the value that comes up with it. So h16 equals negative 16t squared plus 35t, and solve for that. Now, is there a faster way for us to do this? Definitely, okay? So if this was I'm not sure who called, but this is obviously an Algebra 2 class. What if we go ahead and put this into the calculator and look for the 16 in our in our graph and in our table. Where am I? Okay, so back to the calculator. Y equals, let's clear that off. So negative 16 t squared, it's okay if we're putting the x, plus 35, oops, 35x, which is the same as the t. All right, if we graph that, sure enough, there's our parabola. Well, it arced way up, you can't quite see it, but it's there. And if we look at our table and go down to 16 for the height, 16, pardon? 16, oh wait, we're looking for 16 on the y. Oops. 16 on the y, 16 on the y. Well, it's in between 0 and 1. We look for 20. There's 1 is close to 19. I'm not going to show you right now. If we look for 30, is that height possible? 30 is not even on there. It goes 0, 19, 6, and it drops down. So it never got as high as 30, and it's 35 possible. So 19 is the highest mark. That is our maximum, which we could have found faster. Okay, click. So we could have found faster if our maximum. I just did it using the table. So our max is 119 in our graph. So if we come back to the paper, I don't know why I was not putting together what I wanted to say to you. So this point right here, the maximum point is 1, and that's 19. So will the football ever get to 20 feet, 30 feet, or 35 feet? No, the highest it's going to get is 19 feet. So those answers do not work. So it will get to a height of 16 feet. When did that happen? That happened somewhere between the 0 second when you kicked it and the 1 second when we got to 19 feet. Okay, that was a much better way of explaining that. Sorry, I was still focused on my EOGs. Okay, caller, does that help you a little bit? So really, what this problem was really just asking you for was the max of the parabola. Once you found the max of the parabola, you wanted to see if any of these heights were possible. I was looking for the exact value and just wanted to know, was it possible? Will the football get that high? And hopefully on your calculator, let me just go back to that real quick. If you did, with the same equation that's in there, if you did calc and asked for the maximum, which is 4, for a left bound, there's a possible left bound. Let's circle it around. Woo! There's a possible right bound. Do you want me to guess? Yes, I want you to guess. And look at guess, about 1, a little over 19. So there's our maximum value. And that's close to 20, but not quite to 20, okay? And, well, that's good enough. All right. Now, one of the things that, and if a question like this appeared on the test, which it could, because you are supposed to know that equation, you know what, I didn't read the whole question because the most important part of it said, is the given altitude possible? And I was trying to find those given heights, okay? So don't read too far into the question. Be sure you understand it. All right, I hope that helps you. All right, great question. All right, so I'm back to a few algebra problems with 8th grade EOG, and then, well, I guess we'll just keep working on this because I didn't give you any attention the other day. And then I'll come back next week. Most of you will be done, but if you have any questions on any of the stuff that you're working on, just give me a call right now, okay? All right, let's look at number 5. Wow, that's really tiny print for you. See, I even blew these up, but still they're tiny. So get up close to your TV. If your parents ask you what you're doing, just nose to nose of the TV. The price of a large pizza is given by the formula P at T equals 1.5 T plus 7.50, where P at T is the price of the pizza and T is the number of toppings. What does the slope represent? So P at T, so can you picture yourself, you're in the pizza parlor, and P at T, and they would say, okay, let's pretend you're going to have 1 topping. So that would be P at 1. So that means 1.5 T, or in this case 1, plus 750. So the base price of your pizza is 750, and then it's basically 1.5 times every number of toppings. So if you said, okay, I want 3 toppings, you'd say P at 3 equals 1.5 times 3 plus 750. If you wanted a complete garbage pizza and they put all 10 toppings on it, you'd say P at 10 equals 1.5 times 10 plus 750. All right, well, is that answering my question? Well, it is, in that what does the slope represent? Well, slope is that number in front of the x, right, the 1.5. So what is 1.5 representing? Well, every time I add a pizza topping, I had 1, I had 3, I had 10, I multiply it times 1.5. So what that's telling me is every time I have a topping, I'm going to be charged another $1.50 per topping. So what is slope representing in this case? It's not the number of toppings, that's what the T is representing, okay? It's not the cost per slice because that's our final answer, P at 10, P at 3, however number of toppings. The cost of the pizza with no toppings, well that would be P at 0, right? No toppings, which would be 1.5 times 0 plus 750. I'm off the scale here, sorry. Plus 750. So the base price of our pizza is 750. That's like the y-intercept. So what does it represent? It represents the cost of each topping. All right? Great problem because you really didn't have to solve anything. Now, if you had the same problem and they said, you know, how much does it cost for 8 slices of pizza, then you would substitute in 8 and solve the equation. Okay? So break that down. All right, good job. Good question. All right, here's another one. It's a graph. Oh my gosh, we love graphs. This one. What is the graph of the equation? And we're going to zoom in a little bit so you can see it. Now you can really see it. Well, there we go, close enough. What is the graph of the equation y equals x minus 2? All right, before I even go over the calculator, you don't even have to do this on the calculator, right? I know you can do this without the calculator. A couple things you need to know. What is slope? Well, slope is the number in front of the x. It's 1, so slope is positive. And when slope is positive, the graph leans to the right. So let's look at these 4 graphs. Based just on that knowledge, C is gone, D is gone, because they're tilting to the left. That would represent negative slope. Next piece of information which is important to this is, remember this is in the form y equals mx plus b. What is b? Well, b is the y coordinate of the y-intercept. So that would be like 0b. So what is that coordinate? 0, 2. So do either one of these 2 graphs pass through the point 0, 2? Where it touches the y-axis? So where's the point 0, 2? 0, 2. Don't see the line going through that one. 0, 2. There it is. Oh, it's negative 2. Oh my gosh, they got me. Look at that. It's negative 2. See? And I heard all of you thinking that really hard. All right, so we need to look at something else to see if we were going to find the answer. I chose B. As I went through this, I would have chosen B. So you know what I would do after that, even though I did this by hand, is I'd go ahead and pop it into my calculator. So let's look at y equals x minus 2, graph it. Look at that. Does that graph that's on the calculator look like the choice I had for choice B? Well, they're both slanting the right way, but let me darken this up for you. They're both slanting the right way, but this one is hitting the x, or the y, or hitting the y-axis above the origin. The other one is hitting it below. And if you look back at the graph, where is it hitting? If you look back at the graph on the calculator, sorry, it's hitting the y-axis, or it's hitting the y-axis below the origin. So that would just been a way to double check myself. So come back over here. That was a really big error on my part, especially since I'm badgering you all about knowing this. So negative 2 is the y-intercept, which means B is wrong, A is correct. I was just seeing if you were paying attention, just testing you, okay? So be very, very careful. And if you've got time, which you will have time, go ahead and substitute the values into the calculator and make sure they're there. Make sure they work. All right, I think I have time for a couple more. Oh, did we get a call? Okay. Graph this function. All right, let's look at this one. Let's zoom out. Oops. All right, good enough. A bungee jumper, oh my goodness, that scares me just right there, the whole problem. A bungee jumper dives from a platform. The function, h equals negative 16t squared plus 200, I was looking at the numbers, 200, gives her approximate height h in feet after t seconds. Okay, well, I would not be jumping off the platform, so this wouldn't even apply to me. So graph the function. Well, we can graph the function. If we graph it by hand, let's get a few cues going here. Let me pull this down. Couple things you would need to know. First thing, axis of symmetry and the vertex would be a good help. Your axis of symmetry and your vertex. Vertex, axis of symmetry. Both of these are coming from one of your favorite formulas, and that is the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? When the vertex, you're going to look at this part of the quadratic formula, the part I'm circling in red. The negative b2a is the x-coordinate of the vertex. So negative b over 2a. That's the x-coordinate of the vertex. The axis of symmetry, if I was to have a parabola, and how do we know it's a parabola? Because it's t squared. So you know it's a parabola. The axis of symmetry goes right through. It's the vertical line going right through the vertex. And what do we know the equation of a vertical line is? The vertical line is the equation x equals some number. Well, that means it's the x-coordinate. So x equals negative b over 2a. So that's the first thing that will help us out. So what is negative b over 2a? Well, we need to figure out what our a, b, and c are. A, b, and c. What the heck am I talking about, a, b, and c? Standard form would be ax squared plus bx plus c. So the number in front of the squared term is the a. So a is negative 16. B, there is no x term, and then c is the constant, which is 200. So what is negative b over 2a? Negative b, or the opposite of a, so the opposite of 16 is 16 over 2. Oh, sorry. Let's try that again. Opposite of b, b is 0. I've got to make sure we're pulling in the right value. So just 0 over 2 times a, which is 2 times negative 16, which doesn't matter, is 0. So now, how do you find, so the equation, I'm sorry, for the equation for the axis of symmetry then is x equals 0. All right, so we can get through all that mess. All right, so x equals 0. So we know that it's basically the y-axis, okay? Next thing is, where's that vertex? Well, we just found the x-coordinate of it is 0. If I give you a coordinate, or I gave you an x, how would you find the y? Well, there's several different ways you can do it, but one way you would do it, if I give you an xy chart and I put 0 in here, there is no doubt in your mind what you would do. But if I gave you this, some people are like, oh, I'm not sure what I need to do. You would substitute the 0 into the function. So if we substitute 0 into negative 16t squared plus 200, there we, oh, that didn't help you at all, did it? Basically, the t squared is gone. You're left with just the 200. So our 0, 200. So far, we have did that backwards. Come way up here. This is 200. So there's our axis. Other things that we need to know. Does it open up or does it open down? Happy face, sad face. That's all based on the A, isn't it? If A is positive, it's a happy face. Positive, happy, right? If A is negative, sad face, opens down. Okay, it's getting late. I'm a little punchy, but that's okay. So what is this one? Negative 16. So this one is opening down. And some other things that we might want to know are x-intercepts. Where is it going to hit the x-axis? Will it hit the x-axis? Sure will. Look at it, it's going down. It's going to hit them at some point. So how do we do that? Well, we solve for x. Best way to solve for it is to, well, look at it, see if you can factor it first. If you can't factor it, then you can pop over to quadratic formula. So negative 16t squared plus 200 equals, set that equal to 0. Does that factor or solve? Sure does. Let's see what we can do. Negative 16t squared equals negative 200. Divide both sides by negative 16. I need to write here. Woo! Negative 16, you're left with t squared equals negative 200 over 16. Take the square root of both sides. Square root of 200 over 16 is the same as saying the square root of 200 over the square root of 16. That leaves us with t is equal to plus or minus, what is the square root of 200? Square root of 200 is 100 times 2, which is 10 times 10, so 10 radical 2. And what's the square root of 16? 4. And we're all done. No, we're not, you sillies. You always have to be sure that you've reduced everything. Remember I was talking about the radicals when you multiply, insides times insides, outsides times outsides. Same thing happens with division. So we have to divide not everything, don't worry about the insides here, underneath the radical, worry about the 10 and the 4. So 2 goes into both of them. So 5 radical 2 over 2. Do not cancel those 2. So the final answer is 5 radical, plus or minus 5 radical 2 over 2, which is about, if we type that into our calculator, what do I want to do? So 5 times the square root of 2, that number divided by 2 is about 3.5. So t is about 3.5. And since we're just trying to sketch this, negative 3.5, negative or positive 3.5. So there, about, and probably be much skinnier than that because I put my scale is different. So the question, what was the question? Graph the function. Whew, did it. Now, is there a faster way we could have done that? Yeah, technology. So real quick, because I know I'm over in my minute. Y equals what? Negative 16 t squared plus 200. Look at them. They're telling, wrap it up, wrap it up. It's okay. Oh, gosh, look at that. It's way off the scale. So what do? You tell it to zoom fit, and it's rethinking, and there it is. Beautimus. All right? All right, well, that was a great problem to end with. So that should have helped Algebra 2 EOC people. That should have helped you. And next week, I'm going to be back on Wednesday, okay? And remember, it's live on the web, so you have no excuse not to tune in and ask and call your questions, okay? All right, I'll see you later. Have a good week. Bye.